Okay, recall that if vectors are linearly dependent, then so A, I like that color. That means so if A is equal to some m times b plus some n times c, then they are linearly dependent. Okay, that's what linearly dependent means. So the vectors we've got here, they want us to show the ones in part A are linearly dependent. Okay, so last time we did it with like the column vectors and stuff like that in exercise 2A, but this time I, J, and K are the same as thinking of the column vectors, so to speak, right? Because that's exactly what they represent. So if this is true, then that means that there is going to be, for A, if A is going to equal to m times b, that means that, so 8i, so 8 for the A is going to equal, where's the B? M, that is, yep, sorry, M times 1, which is just that, plus n times 2, which is 2n, and actually ends up being simultaneous equations, so it works out better if you number these things. So so in the J's, A is equal to 7, and it's going to equal m times the 1 in B, which is minus m, so minus 1, and n times positive 3 so 3n, and equation 3 is what was it? So A is 3 in the K's, we're thinking about K's here, equals 3m minus n. All right, so we only got to figure out two variables, so let's just use two equations. That looks nice and easy. Okay, so the equation 1, equation 2 has minus 1 minus thing. So if I do 1 plus 2, so that 8 plus 7 is 15. We've got a minus and a positive m, so they disappear, and we have 5n. So that makes n equal to 3. Sub it back in to equation 1. That means that in equation 1, that means that we've got 8 equal to m plus 2 times 3. So m is equal to, that's 6, m is equal to 2. Is that right? Yep. All right. So let's see if, so that means we need, we want equation 3 to be true. So 3 times 2 minus 3 times 1 equals 3. So therefore definitely we can see that A is equal to, what was m again? 2b plus 3c. Okay, so that's my m and n there. We figured that out. That definitely works. So they are linearly dependent for sure. In part B, we've got to show that they're independent. In other words, the dependency doesn't work. So let's just skip straight to the equations. Equation 1, so we've got the same A. So 8 is going to equal m, so we've got I1 there, and obviously they've just flipped around the K here. So everything's the same, isn't it? So if we did the first two equations, we'd end up with I'm just going to skip through. So we'd end up with once again m equal to n equal to 3 and m equal to 2 based on the first two equations, based on 8. This is based on, once again, 8's equal to m minus n m plus 2n. Okay, so 8 I'll highlight it in different color. So 8 is equal to m times 1 plus m times n times 2, and 7 is equal to minus m plus 3n. So we end up with the same stuff again. What was it again? 7 equals minus m plus 3n. Okay, from above. So let's have a look at the last thing we have here. Okay, so 3m, okay, because we're multiplying b by m, plus n. Okay, so 3m plus, what was it? Just n, wasn't it? Equals 6, because 3 times 2 plus 3 equals 9, which is not equal to k in A. It's not equal to 3. So independent. So those A, B's and C's independent. All right, fantastic.